Hey everybody. So today, doing something a little different from the typical community paper reading, we're actually going to do an open source deep dive on OpenAI Swarm, which, as John and I were just talking about, is a project that recently dropped from OpenAI. It's open sourced, it's very experimental, and just want to kind of share out the things that we've learned from looking at it, take away some of the opinions, some of the learnings that we took from it. So yeah, what is Swarm? This was the official announcement of Swarm on Twitter. This post just went kind of viral, and the library really picked off really fast. And so at that point, we just started looking into it. And so what is Swarm? It is an experimental framework for building, orchestrating, and deploying multi-agent systems. So we'll dive into what that means and like what multi-agent means in the context of Swarm. And we're also gonna like compare and contrast Swarm with some other frameworks that also claim to be multi-agent. So before we get into that though, let's go ahead and introduce ourselves. My name is Xander. I'm an engineer on the open source team here at Arise. And I also have with me John, who's our dev advocate. John, you want to introduce yourself?
Yeah. Dev advocate on the Airline team. So I focus a lot on our Phoenix open source tool as well. Doing a lot of our kind of some of our go-to-market stuff around that. And Xander, I will highlight as well because he's being too modest here, has built like a lot of the Phoenix library basically and the Phoenix tool himself as well too. So for those who've used Phoenix and played around with it, you have Xander to thank for a lot of your the benefit that's come from that tool.
I appreciate that, John. Yeah. And this is actually kind of a cool thing because I started out as the dev advocate and John is now our dev advocate. So we kind of have this is our first time doing a presentation together. So it's kind of
That's
like
true.
the dev advocates of Arise, like past, present, and future. So thanks for doing this with me, John.
Passing of the torch. Yeah.
Sweet. All right. So in terms of like what's on the agenda today, we're going to talk about what is Swarm. We're going to talk about why should you care about it? Because, as I said, it's like kind of an experimental thing. It's like not actually published on PyPI. So why should you care about it, right? We're also going to talk about the core concepts in Swarm, and we're going to dive into the implementation. And kind of the nice thing about Swarm, one of the nice things is that it's like really not a lot of code. It's really simple. So that means that we can actually, in the course of like 45 minutes, do a deep dive and pretty much comprehensively understand the library. And I can really show you the important parts of the code. And hopefully you just walk away and you feel like you really understand and you really grok what the library is doing and you grok the opinions that the library has around how to do multi-agent frameworks. We'll do a quick example and demo to kind of illustrate those ideas. And then at the end, we're going to kind of get into like a more high-level discussion where we're going to do like some comparison and contrasting between Swarm and some other frameworks like Crew AI and AutoGen from Microsoft. And we'll also talk high-level discussion around like the role of like control flow in these frameworks. So that's like the agenda. I guess before we jump into like, we're really trying to keep this conversational. So, John and I are going to be talking back and forth throughout the conversation. And like, please feel free. We're monitoring the chat right here. So you can feel free to drop comments at any time and we'll take some moments to take some pauses in between to kind of check out what's in the chat and answer questions as well. So definitely want to keep it conversational and keep it interactive. So with that said, let's go ahead and dive in. So what is Swarm? I've kind of already mentioned at a really high level. It is a multi-agent orchestration framework. It's experimental. It's in Python. It's open source. It's unpublished. So if you want to actually run Swarm, you gotta, do this little command, which will actually pip install it from source from GitHub, right? So it's not on PyPI. Some interesting facts about it, or some unique facts about it, are it's really lightweight, just meaning it's really not a lot of code, really introduces very few abstractions. And we're going to talk about what those few abstractions are. And it's primarily intended for educational purposes. So here is a little disclaimer that the author or one of the authors released on Twitter after it started trending. He said, hey, this is started trending unexpectedly. Swarm is not an official OpenAI product. Think of it more like a cookbook. It's experimental code, not meant for production, won't be maintained. So, that's kind of the TLDR with it. It's maintained or unmaintained by the OpenAI solutions team, really intended for like education.
That's a super interesting point, actually. I'm kind of just, you actually already get a question too around like why do this as an experimental package and not an officially maintained one? Like, do you think they're going to develop it further? do you think that this is a group of folks within the OpenAI ecosystem that are just like, this is a project they made to put out, or do you think that this is, I guess, like, why do you think they went for this like experimental
Yeah.
approach?
I mean, that's a good question. I think we're gonna kind of see like there's a few things, right? Like having looked at Swarm, I think part of it is like it really is not much code. And you could use the code that's in Swarm. You could also just kind of whip it up yourself. They have like a few things that I think they're trying to say are like nice ways of doing things, right? So we're going to talk about these, but things like, hey, did you know you can actually just define functions and define some syntactic sugar to like get those functions into JSON schema, right? Little ergonomic things, or like, did you know, like, if you want, you can just run things in a while loop, right? And you can have this idea of an agent, which is just this really simple thing, that has like instructions and tools, and you just have one at a time and you run it in a while loop. I think those are the kinds of opinions and ideas they're trying to promote, without necessarily promoting any particular framework or any particular implementation. But those are kind of the takeaways that I took away. And so I think in terms of like why they don't maintain it, not sure. It is maintained by the solutions team, but I think they're just trying to show like, hey, this can actually be like relatively straightforward. If you want to just start with like kind of a base implementation, and that's all you need. You need a while loop and you need this idea of an agent. Yeah. Yeah.
Makes me wonder if they had some people who were they were seeing people overcomplicate agents in practice, and they're like, guys, it's actually simpler than you think. Like, here's the example.
That's like honestly one of my takeaways as well. Is like, keep it simple, right? Like really there's a lot of value in keeping it simple. And I think by the end of this, like hopefully you see like, yeah, you can keep it quite simple. And that's what they do. So along those lines, right? Like why Swarm? Like it is really simple, right? It's kind of refreshing actually. Like if you've spent time with some of these like more complex frameworks, it's really refreshing to just get a really simple take on how to do multi-agents. So I really appreciated that. And like we were saying, like I think this segues just from what we were just talking about, but like I think a lot of the opinions and lessons and teachings of Swarm, I think you can use them whether or not you actually use this particular implementation. So that's why we wanted to cover it today. Um, so let's go ahead and dive into some of these concepts. Like, we've got this concept of an agent that we've been talking about, and I think that word's pretty used pretty heavily these days. But in Swarm, it has a pretty specific meaning. So an agent is just a thing that has tools, and these tools are actually just going to be defined as Python functions. Um, and it's also got instructions, and that is really just a system prompt. And that is all an agent is. You can actually see the actual implementation of an agent down here. This is the actual implementation from the code. It is literally just a Pydantic subclass, subclass of a Pydantic base model. You just pass in your instructions in the form of a prompt. You pass in functions. So these are the tools. They kind of use this term function or tools interchangeably, but you'll pass in some functions, and everything else is kind of auxiliary, name, model, whatever. This is all an agent is, though. Tools and instructions, you have an agent. Control flow is a while loop, as we mentioned. So there's nothing really mysterious going on there. And there's one assumption, though, that is going to be important, which is that even though we're going to have many agents, there's always going to be exactly one agent who's in control at any given time. So that's a well-defined thing, one agent at any given time. And we're not going to do anything around parallelizing. We're not going to do anything, just simple, one agent at a time. And importantly, some of these tools that we're going to define as functions are going to have this ability to hand over control of which agent is in control from one agent to another. And so the agent is going to be able to basically say, hey, I don't have, the skill or whatever, or the tool that I need in order to solve this task, but I do know another agent who does, and let me route you to that agent. So this is the high level of how Swarm works. And then if we dive into like how tools work, as I said, they're just Python functions. And this was like one of those, I think, really nice things that I think we're seeing in, John, correct me if I'm wrong, but I think we've seen this in some other frameworks, which is that they do a nice thing for you, which is that they translate the function, which is defined in Python, into this nice JSON schema for you automatically, which I think is a really nice thing. And like you can write that code like whether or not you're using a framework, right? But you can see this is what the tool looks like in the code. They'll transfer that into this JSON schema for you, where they grab the name of the function, they grab the doc string here. So I like this, and it's pretty straightforward. And
I will, if I can jump in really quick on that, because
go
I have
for it.
my own take there. I think
Yeah.
it's really useful, but one thing that's really annoying if you're building with any of these agent frameworks is that the description of the tool and the description of the parameters that are passed into that tool really, really matter for you to get your agent to work well together. And so I think one thing we will probably get into more later is I think one thing that they call out in Swarm is that they don't necessarily have a way to like really clearly define, okay, this parameter into your tool should be X, Y, and Z. I think that's something we'll kind of get into a little bit more later. But I think this translation is very nice, but it's frustrating if you like need to really specifically modify some of the text and descriptions out of certain parameters that are being used. But I think it's a good paradigm. I think it's just like there's a little kink to iron out of like, if I want to go in and modify exactly what even just like not just description of a function, but description of a parameter to that function is,
Mhm.
then it needs to be kind of clear where I do that. And then so it's nice to see that they're going for this approach, which a lot of other providers are doing. Like I see people calling out in the chat, like LangChain's tool decorator works in a similar way. So it's nice that we're moving towards this paradigm because then people can learn, okay, this is where I go to modify that text, for example.
Yeah. Yeah, that's a good point. I don't think they do. To John's point, I haven't tried it out, but I don't think they would do the thing where you would like be able to it'll pick up the parameters and it'll add them like as required or not, but I don't think
Mhm.
it will like do a doc string from the parameter itself in Swarm. That strikes me as something we could totally do though. So it strikes me as like a nice little, very useful little open source package that somebody needs to create that just like that does
Yeah,
all that and like really exports the tool schema to different model providers. Yeah, yeah,
yeah.
yeah. Well, then on the topic of functions too. So there's a couple things functions can do, right? Like they can do arbitrary logic, right? So you could put inside of your function a call to an API or a database transaction or whatever you want, right? But some functions in Swarm are also going to be special. And this function right here that I'm showing you is actually one of these special handoff functions. And a handoff function is the one that Swarm uses to basically pass control from one agent to another. And literally in the handoff function, all you do is you return the agent that you want to pass control to, and that's it. So this is the Swarm mechanism for passing control. And then let's just go through an example. So this example we're going to go through is airline customer support. So imagine you're trying to build a multi-agent system for handling customer support queries for your airline. So this one has 5 agents listed here, and we can go through them. And then I think the kind of like high level thing is like we got a user request coming in, and then these 2 agents, the triage agent and the flight modification agent, are really going to be responsible for like routing requests. The only thing they're going to be doing is like which department do I like send this request to so they can resolve it, right? Um, and all these black lines, these are visualized, these black lines are representing like those tool handoffs. So the routing from one agent to another. And then you can see down here at the bottom, some of these agents also have additional skills, right? So in addition to the ability to transfer back to triage if they need, this flight change agent has, for example, the ability to escalate back to a real agent, like meaning like a human being, has the ability to change a flight, has the ability to um, validate. I think this is like some kind of validation thing and has the ability to like resolve the case, meaning like, hey, this case is over. The user got everything that they needed, right? So the idea is we're going to start out up here. User's going to come in, hit the triage agent initially, and then depending on what their request is, they'll get either transferred to this lost baggage agent if they have lost baggage, or if they say, hey, I need to like make some kind of modification to my flight, whether that's canceling or changing, I'm going to transfer here. And then if they transfer here, there's a further routing step. So it's like a sub route to either the cancel or the change agent. And I'm going to show you actually like what this looks like in code, because this picture really is like very, very close to the actual implementation in code. Um, so what does that look like in code? Let me see, I got to open up Swarm. And so in terms of code, here in the code, we're actually just going to define those 5 agents that I mentioned. So we got triage, flight modification, flight cancel, flight change, lost baggage, right? And so those are just defined right here using that agent interface that I showed you previously. So there they are, flight modification, triage. And you'll notice that all of these agents, they also have these functions, right? And again, functions, tools, interchangeable terminology in Swarm. So the triage agent, has these 2 tools that are these transfer tools. So transfer to flight modification, transfer to lost baggage, right? But some of the other agents, like maybe I'll take a look at this flight cancel agent, in addition to this transfer back to triage tool, which is defined right here, they've also got all these other tools, which are like their specific capabilities that make them good at what they do, right? So, we mentioned some of these before, but they in particular they have the ability to like change the flight, and that's really it. And if you click through on some of these, these are just functions, and this is kind of a toy example where you could imagine inside of this change flight function, you might actually implement something like an API call, and if this were a fully fledged application.
One thing that's kind of cool to call out here too, that's just a happy byproduct of this is because you have this platform using kind of function calling to move between the different agents, essentially. You could basically, from an evaluation perspective, you can do function calling evals, and that will cover both of your kind of choice to use a certain function as well as like your kind of pathing through the agent. So kind of a little fun bonus fact of like if you're setting up evaluation for this, it actually gets a little easier to do in Swarm than it is in some other providers as well.
Yeah, do you just mean like because it's such a light abstraction? I mean, it's really just
Yeah.
a small wrapper around the tool calling API for OpenAI.
Yeah, essentially, like you can just you basically just have to evaluate how good a job does each agent do at function calling, and then whatever else that particular agent does to kind of measure how good is it at choosing the right path for the agent.
Yeah, and I guess that's like one of the features again of Swarm is just like really the not a lot of abstraction, right? Like very thin wrappers around the underlying OpenAI API, and then just kind of organizing everything in a way that the prompts are nice. So
Yeah,
yeah, I think that's a nice feature of it.
yeah.
Yeah, for sure.
We did get a question as well too as we're going through here, which is like how is this different from microservices?
Uh-huh.
So I guess then a question for you like is thinking of the agents themselves as like microservices. Like, do you think that that's sort of a good way to think about them, or like a sort of transferable definition in a way?
Oh, I guess by analogy, maybe. I guess they're not exactly microservices as you're going to see in the sense that like it all runs in the same runtime, right? So maybe that would be like the main distinction. Like the triage agent, the flight modification agent, the flight change agent, they're all running in a while loop in the same runtime. Um, I think, yeah, maybe the way that I'm thinking about agents, like why even have them, or like what good does it do to like break up this system into multi-agents? Like why not just have one prompt or one agent? Is I think it's kind of like mainly a way of organizing your prompts and organizing your tools and your code in such a way that your prompts are simpler because each agent is responsible for fewer things, and has to know less, right? So your prompts wind up being scoped to a very particular task. And then each agent also has access to a fewer number of tools, right? Um, as opposed to having like just all the tool calls that all the things you could do all at once, it has just access to a few number of tools. So it kind of like conceptually, I think makes it easier to think about the organization of your project or of your software, um, and limits the number of tools and simplifies the prompt. So I think those are the main benefits, right? Um, yeah, yeah.
Yeah, makes sense.
So let's see. After we've defined these agents, we have an entry point. Um, and I think the entry point that they ship by default is called run demo loop. Um, I don't know that you would actually use this in a productionized application, because it literally says demo in the name, and it's printing and interacting with like standard out. So probably wouldn't use this in an application, but we'll look at what's inside, right? But the basic idea is you have an entry point, and to this entry point, you pass the initial agent who's going to have control, just the triage agent in this case. And you pass some context. So in this case, the context is just a dictionary. It's got a few pieces of information in it. It's got customer context, which is like information about the user that this agent is talking to. So in this case, we've got some customer details like phone number, email, balance, their address, etc. And then it's also got a flight context. So the agent knows like, hey, this customer actually has an upcoming flight from LaGuardia to LAX, and this is the flight number. So that's the context that's passed in, and all that happens inside of this run demo loop is it really is just a while loop. So we just start up the swarm, and this swarm abstraction is just like putting together all those agents that we defined in that previous step. We got some message history. So these are like literally the OpenAI messages, the list of messages and interactions between the user and the API. We got the starting agent, and then you just run a while loop, solicit input from the user, in this case via the command line, update the message history, and then just run this agent basically, and you get back some output that you can display to the user. And then here's maybe the important part at the end here, you have the option of actually updating the agent in charge. So now at this point here, if there is a new agent that you have pointed to with your tool, now that agent is updated. And this is all there is to it. So I guess we got a question real quick, and then I'll hop.
We got
Yeah.
a few that we can dive into. Let's maybe start with the bottom one because I think that's the most straightforward. Can the agents themselves be parallelized? Can you run them in parallel? Is there like an asynchronous element to this at all?
Yeah, that's a good question. That's a good question. So I want to say no. And I think, I mean, it's a good question. Like they have this thing about parallel tool calls. Not sure exactly what that does, but I think from what I've seen, like all the examples I've seen are just a while loop.
I can speak to the parallel tool calls if that's helpful.
Oh yeah, go for it. Go for it.
Yeah, so I think that's referring to like when within a particular agent, that agent might decide to call multiple tools that it has access to. And so you might want to execute those tools, sort of the function that's associated with those tools in parallel. So you can have like, so say you have your like maybe your flight cancellation agent can do like both cancel the flight and like update a record as two different tools in parallel. But it wouldn't it wouldn't necessarily be agents themselves working in parallel. It would be that particular agent can do its tool calls in parallel.
That sounds right to me. Yeah. So I don't think that's the kind of asynchronous agent that you're maybe referring to in the chat. So yeah, I think like it is an assumption that these agents are going to run basically one at a time in a loop. And again, like the main assumption I think that I've seen is like one agent is in control at any given time. So maybe that's a limitation, right? Like maybe there are cases where you would need to break that paradigm, but I think certainly it's a really simplifying assumption as like a baseline assumption. Like if you're trying to build your application and you're trying to just get a baseline out there and see like, hey, does this very simple implementation actually work for me for my use case? Like that's a pretty nice assumption because as we're going to see, it actually makes things really like easy to think about, you know? Let's see what else we have in the chat, John.
There's one about comparing to LangGraph, which I might hold on for a minute until we get to the comparing section because that's a good one.
End,
yeah, it's a good one to dive into. And then there's a question from Daza about getting the actual examples to run because we've pulled an example from their Swarm example notebook. Sounds like they've run into some issues getting those notebooks to run actually. Xander, I know that you went through.
Yeah, like I think some of their examples are broken, so I may have had to. I don't quite remember. Some of them I had to fix in their repo, and you know we can like point you to the location of where this lives at the end.
Yeah, awesome. We can share that. I think that'd be helpful for people.
Sweet. All right, cool. Well, let's go ahead and oh, I guess there's a question. So each agent does not have its own LLM. They're all leveraging one LLM, which calls the tools, which are agents. Yeah, they're all like are using the same LLM under the hood, and you know this is an OpenAI library, so there's no model interface to other providers. They're just using, in this case, I want to say GPT-4. Yeah. And is this only for flight projects, or can it be for other projects? Maybe not quite following what a flight project is there, Alexander.
It might be actually maybe you have more info, but it might be that we're going over this airline example. This is just like one example in the repo of how you could use it. So you could totally use it for other projects.
Yeah, they've got like 5 different examples, some of which I didn't get running because they were a little bit broken. And then I think I got most of them running. All right, cool. Let's go ahead and check this out. We'll come back for more questions soon. Um, so to start this out, I'll go ahead and launch Phoenix. And this is just with like kind of on an experimental fork that we were doing. So we don't have OpenAI Swarm instrumentation. And for reasons that we can talk about at the end, I don't think we will. But it's kind of an interesting question about why we probably won't. Um, and let's go ahead and start this out. So I got a Swarm project here. It's empty. And I will go ahead and switch over. And again, like this run demo loop abstraction that we're using, it really is just soliciting user input from the console. So this is the airline example. So first thing that happens is it solicits input from the user. So maybe the user types in something along the lines of, um, hey, I need some help. Something really vague and generic. How can I assist you today? All right. And let's say I need to change my flight. Oops. Need to change my flight. All right, so a bunch of stuff just happened, as you can see from all this output on the screen. And I won't try and parse this output on the screen. Let's go ahead and like take a look at what's happening inside of Phoenix, right? Um, so what's happening inside of Phoenix? In this trace, you can see my last message was I need to change my flight, right? And let's actually take a look at some of the system messages and tools and everything, right? So you can see here the system message is you are to triage a user's request and use a tool to transfer to the right intent. So this is actually the system prompt for the triage agent. And if you notice, we also have two tools, transfer to flight modification, transfer to lost baggage, which if you recall, jumping back up to this diagram, these are the two tools that the triage agent has access to. So all that is to say, in this step right here, the triage agent is in control. And we can tell that just by looking at the tools and looking at the system message. And so you can also see the other interesting thing that happens is all of that context, right, that I passed into the entry point into the run demo loop, it all gets stuffed into the system prompt as well, so that the agent knows who it's talking to. It knows that it's talking to John Doe. It knows that I've got this flight coming up from LaGuardia to LAX, so it knows these things. And really, this prompt is just asking the triage agent, hey, you can route here or you can route there. You've got these two tools, so send the request one way or the other. And then in the next request, you can see here, back here, we have this transfer to flight modification, right? So it says, hey, transfer this to the flight modification agent. And then in the next LLM request, this is all in the same iteration of the loop, but in the next request, the system prompt is changed. So you are a flight modification agent. And if you look at the tools, I've got two different tools. I've got transfer to flight cancel, transfer to flight change. So these are these two tools, transfer to flight cancel, transfer to flight change. And then if I come down one more, or actually, no, let me look at what the output was before I do that. If I actually look at this output here, the LLM is telling me, hey, transfer to flight change, right? The user requested to change their flight, so transfer to flight change. And then here, once again, the system prompt is changed. So now it's not actually explicitly saying this, but this is the flight change agent system prompt, and it's providing explicit instructions that are scoped to the tasks that the flight change agent needs to know about, right? So it says it needs to verify the flight details and the reason for the change request, needs to, first of all, validate that this is indeed a valid flight to change, right? Suggest a flight one day earlier, check availability, et cetera, et cetera. So it's got a sequence of steps that it wants you to follow. And then again, the tools this time, you can see there's a lot more tools, right? All of those tools that the flight change agent has are now available. So again, this is driving home this point, like in Swarm, all the agent is, it's really a very concrete thing. It's just a system prompt and a set of tools. That's what makes the agent who it is, basically. And so at this point, like, let's go ahead and just finish this thing out, and then we can take a peek at what's going on under the hood. Could you please provide the current flight details and the reason for the change request? Sure. I'm flying to LAX. I'll say flight 1919. I need to change because something came up with work. Something like that. All right, so a bunch more stuff just happened. I'll go ahead and finish this out too, so we can just look at it all at once. So thank you for providing details. Your flight is eligible for a change. I suggest considering a flight 1 day earlier. Let me check availability. Could you confirm if this works for you? Works for me. Right, and so it's checking for availability, one flight 1 day earlier, has seats available. Would you like to proceed with this change? Proceed, please. So that whole time, actually, the flight change agent was still in charge. Your flight has been successfully changed from 1 day earlier. Please let me know. No further questions. That's all I need. All right, case resolved. So we're going to see when I look now at the, I won't dive too much into the details there, but I'll just show you the history of messages that we've gotten since the last time we checked Phoenix, right? So the last request that I put in after I got to the flight modification agent, the agent asked me like, hey, could you provide these details? I say, hey, yeah. I give them the details. They first of all call a tool. So they call this validate the change flight. So they're like validating my flight number. And the tool response is like, oh yeah, the customer is eligible. This is fine. They replied to me. And then they call a couple of other tools. They call the change flight tool and they call the case resolve tool. And so this was all by the flight modification agent. So that in a nutshell is like how Swarm works, right? Like it's just transferring control from one agent to another, which really just equates to like changing the system prompt and changing the tools that are available. And it just does this in a while loop, transferring control from one to another. And that's actually really it. So let's maybe just pause and discuss and see if there are any questions.
There's a ton of questions we've been getting as we go through, I think, so we can cycle back through some of those. Let's see. So yeah, there was one point about hey, like this is basically using an LLM for everything here, like for like transitioning between different tools, etc. In a real world case, would you want to use, is that okay to use an LLM for everything, or should you use some combination of like code and LLM as you're defining your agent? I have my own opinion on this one, but Xander, I'll let you jump in if you have any thoughts there.
I mean, that's a good question. I mean, I think the idea is certainly to use code as well, right? Maybe I'm not quite following though. Like, you got to use code for things like the tools, right? The task-specific tools are certainly going to be implemented in code, right? So when that change flight tool that gets called, it's probably making an API request or a database call or something, right? Yeah. In terms of like, are we using code for routing? Maybe that's where the question's getting to, right? I think you got to just do what works, right? It's certainly fine to use heuristics. So if you have heuristics that you can actually write in code, like why not use them, you know? I think that's perfectly fine. And I think the idea with Swarm is that the notion of a tool is sufficiently flexible that it would allow you to do that, right? So you could define a tool that has some kind of code heuristic that is a handoff tool that, you know, if some heuristics are met, it passes control to a specific agent. You could totally do that. I think that's a totally reasonable thing to do. Yeah.
Yeah, because there's a thing in Storm that I don't think we talked about that. If you can return agents as the like return value of a say a tool, and then that will transfer the control over to that agent. So
Yeah.
you
So
could actually,
literally, it's pretty straightforward. Like in terms of the implementation of how you like transfer to a particular agent, you can see these tools are really simple functions, right? So this is the handoff tool to the flight modification agent. And this flight modification agent it literally just returns the agent object in the code. That makes sense. Yeah.
So you could kind of combine them. That's cool.
You could totally combine them with this. Yeah.
Awesome. We had a couple questions around what the UI we're using is. So this is Phoenix for anyone who hasn't seen it before.
Yeah.
Everyone should check it out. It's our open source observability tool. So if you haven't seen it before, super easy to use and very very helpful for situations like this. Yeah, we had another question around like what other real world use cases we can use Swarm or multi-agent frameworks for. I think there's a few that come to mind. I think there's a few examples in the repo too, but I think any of these sorts of routing or like a customer service kind of use cases, I think are an easy one. I think some other ones that we've seen people using them for have been like any kind of like triaging capability that you need where you're going to route some sort of request into different areas. Yeah, Jenna, I don't know if there's others that come to mind for you.
I think, yeah, I think that sums it up, right?
Yeah.
I think the nice thing about the multi-agent thing is that it really does make your system easy to understand in Grok and easy to explain to yourself, right?
Mhm.
So I think the thing I was struck by when going through this particular example is like by splitting this up, as we already mentioned, you make the prompt simpler, right? You make the routing simple. You make the tool calls scoped to a particular set of prompts that actually like describe, what is relevant to those tool calls and everything. And every agent has access to fewer. But in addition to all of that, right? I think you kind of wind up with this organization of your software in a way that's like kind of easy to explain, right? Um, like this is like kind of
Mhm.
like what a customer service system made of real human beings would look like, right? You might have some people who are responsible for routing top level requests, and then you have some people who like are really specializing in specific tasks. And so I think from that perspective, like it's something worth trying just from the perspective of organizing your code, you know? Um,
Yeah.
yeah.
Um, we only have a few minutes left, and then there's a couple questions around the instrumentation that I think might be helpful to see to talk
Mhm.
about too. Well, so actually, there's one that we can tackle really quickly, which is can you check the total tokens and total costs, things like that, that are used in the instrumentation? And yes, we do track token usage and things like that, so you can see that within Phoenix. That's something that we're grabbing there, which is
You can
useful.
see these token counts here. Yep.
Mhm. And then there were two questions on the instrumenters and instrumentation. One was, does our current OpenAI instrumenter trace swarm flows? And then the second was kind of where do you add the instrumentation code for swarm? So maybe just be helpful to talk a little bit about what we've done here versus how that compares to our existing OpenAI instrumenter.
Yeah, yeah. So in terms of the instrumentation on this one's using, um, I'll show you what it looks like, but it is using a combination of our existing OpenAI instrumenter, which is responsible for instrumenting the OpenAI client in particular. I'll show you the entry point here. Yeah, so this is just some boilerplate that we have in Open Inference that is setting up Open Telemetry, which is a tracing, open source tracing package and system. Um, so this is our OpenAI instrumenter, which is responsible for tracing the calls made by the OpenAI SDK, the Python SDK, the client. And then this also had like an experimental Swarm instrumenter, which is not released, which for reasons that we can talk about, we probably won't release. Just because there's not really a huge amount of meat on the bones of Swarm. It's really like very lightweight. But this is like it's a little experimental, right? So it's a combination of some instrumentation that's published and some that was very experimental. Yeah,
And if I'm understanding it right too, the OpenAI instrumenter is basically giving you the orange LLM traces that we see over
exactly.
here. So it's giving you all that. So you would still get those kinds of views with the just the default OpenAI instrumenter we have.
Yeah, yeah. So these, as John is saying, like these LLM calls are coming from that OpenAI instrumenter, and these ones are coming. The blue ones are coming from the Swarm instrumenter that's experimental. Yeah. All right. John, I want to make sure to reserve
Yeah,
some time for you. I'm sorry I've gone over.
no, this is great. We got a great questions. That's exactly what we want. So I'll quickly kind of just talk about Swarm compared to other frameworks. And we only got a couple minutes, and I'll try to touch on LangGraph and CrewAI, which were two that people mentioned as well.
Mhm.
Um, Short answer with this is that a lot of parts of Swarm look very similar to other multi-agent frameworks like CrewAI and AutoGen. And then a lot of there's one kind of big difference that we'll talk about. So what we have here is that, and we'll link a thread that goes through more of a detailed comparison of those. On the left side, this is code that you would use to define the individual agents within the multi-agent framework. So you can see Swarm versus CrewAI versus AutoGen are really very similar. I think one of the biggest differences is that with CrewAI and AutoGen, you can use other non-OpenAI models to power that particular agent. So there's some config you can add in around that. But all of them really have this idea of like name, system instructions, and some tools that are attached. AutoGen, you define the tools just with different syntax basically later on. So there's some mild differences there. And then the tools themselves that you give to these agents are, again, really similar. You have basically functions that are going to be representing those tools, and we read from the doc string to kind of create the different the entry that goes into the LLM for use for function calling. True AI makes a lot more use of decorators on top of the function that will do that as well. And then AutoGen additionally supports things like you can actually see in the parameter definition, the annotation that we add there to say what that particular parameter is.
Mm,
So with True
that's
AI and
nice.
AutoGen, yeah, you can like define, okay, this is what that parameter should be in natural language. Swarm
And
doesn't have
does
that.
that get mapped over, John,
Yeah, that gets mapped over, which is
into the
really
schema?
useful.
So that,
Yeah,
oh, that's sweet. Yeah, that's, I
yeah.
think that's really nice. Yeah.
Yeah, so that's kind of like the one, if I had a big gripe with Swarm, that's that, because you really do need to modify what those descriptions are.
This syntactic
Um,
sugar is lovely. I love that.
yeah, yeah. So I'm sure they'll add that if they keep working on it. But yeah,
Yeah.
so similar on the tools and the agent side, I guess the biggest difference, if you go one more slide, Xander,
Mhm.
is more the kind of organization of how the agents work together. So in both Crew AI and AutoGen, which are admittedly more mature frameworks, like they've been around for a longer time, Crew AI, like it's the main product that a company makes, for example. So there's like more kind of, it's not exactly fair comparison. But both AutoGen and Crew AI have all these notions of how you organize your agents. So there are like literal objects in AutoGen, like group chat is a sort of object that you can create that combines multiple agents together. Pipelines is one in Crew AI. And these let you define how the agents work with each other in a much more structured format. So you say, okay, like this agent works and then this one, and then this one, and this one, and that's a pipeline, and that pipeline is used for XYZ. And then you can kind of define them more. Swarm doesn't really have that same kind of thing. We looked at it just basically as using function calls to move from one agent to another. So you do define how you move from one agent to another with those, but it's very much like the current agent abdicates control at some point and moves over to another agent versus having these much more defined structures. So I think that's kind of the biggest difference in my mind is that you have those there. I'll touch on LangGraph quickly because I see people asking about that as well too. Um, LangGraph you could compare as well. LangGraph is almost, I tend to think of as like a level lower because it's can be used for kind of really mapping how an individual agent will work as well. So in LangGraph, you can define kind of nodes and edges, and you'll move between different nodes and edges and do things at those realms. So you
Mhm.
can use LangGraph to define a multi-agent workflow. You can also use it to define just a single agent. It's a little bit more low level and it's a lot more kind of controlled. So I think if you wanted to be very specific about how your agent would function, LangGraph is a good kind of option for that. And actually, LangGraph is used under the hood by Crew AI. So a lot of the same kind of comparisons we're talking about would apply for LangGraph as well here too. But yeah, I typically think of LangGraph and like Llama Index workflows as almost a more lower level. It's like single agent definition, but there's no reason you couldn't define a multi-agent flow. It's just that you're doing a lot more kind of syntactic definitions with those lower level frameworks to make a multi-agent one work versus some of the ones we've looked at here are trying to add another layer of abstraction so that defining an agent is a few lines of code as opposed to being a much more detailed kind of thing. So I think they have different applications in each one.
Yeah, so if I'm
Yeah.
understanding correct, John, right? Like
Mhm.
maybe one of the big pieces here is like AutoGen, Crew AI. They really have primitives that are around like control flow, how control flow works, and they've got like pretty strong opinions there. And maybe Swarm like just doesn't have those opinions and basically like leaves it in user land or leaves it in the application developer's hands how they do that. And it
Mhm.
sort of sounds like maybe it's a similar story with LangGraph and Llama Index workflows, where it still is lower level and there is this kind of like graph-like structure perhaps that you can define. Does that sum it
Yeah.
up accurately?
Exactly. Yeah, you're much more defined about exactly what values go between each of the nodes in your graph, for example, with those kinds of frameworks. So you have much more control, I would say, versus you're kind of leaving things up to how the LLM wants to move at a certain moment with some of these more multi-agent
Mhm.
approaches.
Mhm.
Yeah.
Yeah.
So
Yeah, I think that makes sense. Um,
yeah,
well, cool.
um,
I guess at this point we're pretty close to
we're
the
kind
end.
of up on time. I think we might
Um,
have to leave these
might have
for a
to,
future one.
yeah, yeah. But I think yeah, the one of the things that we were thinking about is just like, are we converging on this definition of a single agent? And well, maybe I'll just end with that, John. Like, what do you think? Um,
Yeah, I mean, it's interesting that you have very similar approaches within Crew AI, Auto, and now Swarm of like this is what an agent is. It's a thing with tools and instruction. and that's kind of the main area for it. And so I think that it's interesting. It's nice because I feel like we're sort of converging to, okay, this is what an agent looks like. We now have 3 independent providers that have landed on the same thing.
Mhm.
There's an open question of how you define control flow, obviously, but it is interesting that I think we're starting to kind of have a more common, at least code definition of what this sort of high level abstraction of an agent is.
Yeah. Yeah.
Yeah.
That's super interesting. All right. Well, I think we're just about up on time. If you have any leftover questions, why don't we just direct people to community and we'll answer them there. So just hit us
Yeah.
in the Arise AI Slack community. Maybe we can drop a link for that. And
Yeah.
thanks so much.
Yeah, and if you go one more slide, I want to highlight one session we have upcoming too here actually before we hop off. So we do also have a we're for anyone who caught us, we did a whole like 6-part series on building agents. That's all online too, and we can direct people to that as well too. We just wrapped that up. That was super successful, and so we're doing a kind of sequel series to that now, where we're looking at real world examples of agents and assistants. So this is a combination of our own agent that we built, really deep diving into the code there, as well as we're going to bring in some guest customers, hopefully here to kind of demo and talk through how they've structured agents. So this is less of what does it look like to build an agent, but it's much more of okay, here we have a bunch of real world examples. Let's dive into each one in detail. And so this is starting. Sarah, correct me if I'm wrong in the chat. I think it's starting next week. I want to say starting next week. Awesome. So we'll have another 5 or 6 part series. I think we're still finalizing that. That we'll go through in these, and we're really excited to deep dive there. So if you're wanting to see more about agents, more examples, then this is then make sure you tune in for that.
Awesome.
Yeah.
Cool. Thank you, everybody.
Thanks, everyone. Take care.